Hello students. So yesterday we have done problems based on combination of the magnetic induction at the center of circular loops, arcs and straight current carrying conductors. Okay. So few more models we have on that. So today we will complete the remaining models based on that two conductor. Actually this is application of Biot-Savart's law. We can say it is application of the Biot-Savart's law. Okay. So now let us see the next model here. A wire of length 22 centimeter is bent into a semicircle of a semicircle and a current of 4.9 ampere and a current of 4.9 amperes passes through it. Okay, passes through it. Then what you want to find? The intensity of magnetic induction at the center of semicircle is. Then the intensity of magnetic induction or magnetic field, magnetic flux density, all are same only. Magnetic field at the center of semicircle in Tesla is. Semicircle in Tesla. So this is one model, no? This model we have not seen. So first we have taken one wire. So we have taken one wire here. Just see the beginning of the solution here, how to solve the problem. So it is a wire. We have a wire here, right? Suppose this is our wire. What is the length of this wire? 22 centimeters. 22 centimeters. The wire is 22 centimeters. So what we have done now? This 22 centimeter we have converted into semicircle. It has been converted into a semicircle. It is converted into a semicircle. That means what? What is this? The circumference of the semicircle will be 22 centimeter. So what is circumference of the semicircle? Pi r. Because for circle it is 2 pi r. So semicircle it will be pi r. So what we have to calculate now? We have to calculate what is the radius. For that only this has been given. Radius directly not given here. So first we have to calculate what is the radius. So for that we have circumference of circle pi r is equal to 22 centimeter. Therefore r is equal to 22 by pi. So once we know this, once you are able to identify that, we have to find out what is the r value, then we can calculate what is the magnetic field at the center of the semicircle. So what is our formula now? What is the formula here? You can take standard form also. Mu naught by 4 pi into I by r into theta. Suppose if you don't remember what is the formula instantaneously, then you can take general formula also. Mu naught by 4 pi into I by r into theta. So theta is how much for semicircle? It is equal to pi. Therefore mu naught by 4 pi into I. Now substitute for r. It is in centimeter. That is very, very important. It is in centimeter. Therefore it should be converted into meter. So 22 into 10 power minus 2. So 22 into 10 power minus 2, because that is should be in meters. So 10 power minus 2 into R. R is how much? 22 by pi. 22 by pi. So pi gets cancelled now, isn't it? So pi has been gets cancelled here. Then then we can have mu naught by 4. So that we can substitute now. So that can be substituted now. So here that will be equal to, we have, so that is equal to, we can write now. Let us substitute. Mu naught is how much? So mu naught equal to 4 pi into 10 power minus 7 into I equal to how much? I equal to 4.9, isn't it? I has been given as 4.9, right? So divided by 4 into 22, 4 into 22 into 10 power minus 2 into 22 here. So what we will get here? Current is 4.9. So therefore it is equal to 4 gets cancelled. 20 pi we can take 22 by 7 into 10 power minus 7 into 10 power 2, because this will be brought to numerator, it will become 10 power 2 into 4.9 divided by 22 into 10 power 2 already gone. So 22 into 22, 122 gone, and 7.7. Okay. So now what we have here, 0.7. Therefore it will be approximately how much we will get? So approximately it will be equal to, we are having 22.2. So that will come as equal to 2.2 into 10 power minus 5. So 2.2 into 10 power minus 5. Okay. So that is the value of this one. So different options are given. The correct option is 2.2 into 10 power minus 5 Tesla. Right. So that is the value. Okay. So now next model. We will go to the next model now. So in the next model we have, so these are all these models what I am doing now, this problem onwards, they are asked in JEE Main or MSET or NEET for last 2-3 years, right? These are all last 2-3 years problems. So now let us see the problem. An electric current flowing in a very long pin as shown. An electric current, electric current is flowing in a long pin, long pin as shown. Long pin as shown. Find the value of magnetic flux density at point O. Find the value of magnetic flux density. Magnetic flux density at O. Density at O. That is center of the semicircle. Just see this. So this is the pin. So this is the pin, and this is the center O, right, and it has been given radius equal to r, radius equal to, it is given r. So the pins are also given A, B, C, D and E. That is the pin. Okay. So now here we know already this model. We know for semicircle, we know for a straight wire, semi-infinite straight wire, semi-infinite straight wire. Sometime they will show like this also, infinity, here also infinity, like that also they will show. Okay. That means what? Semi-infinite, here it is end, one end you are calculating. That means this will become 0 now. The angle is going to become 0. For this both theta 1 is equal to, I can write this end for this, and this is beginning. So for this theta 1 equal to 90 and theta 2 is equal to 0 for this wire. For this wire, theta 1 equal to here 0, theta 1 equal to 0 and theta 2 will be equal to 90. Values remain same only, but wire, this is infinity this side and this is coming from infinity. Therefore, that will be 0. Then what is our value? For both of them, value will remain same only. So B is equal to mu naught by 4 pi into I by R into, for both of them, one will be 0, other one will be 1. So for semi-infinite wire, the value will be mu naught by 4 pi into I by R. So for both of them. Now let us see what is the direction of the field. Take our right hand, I told you, right hand thumb rule. So see this is the direction of current. We are holding like this. We are holding like this. See what is happening here? This side means upper side. See the upper side. Upper side, it is coming out of the plane, isn't it? This is what you are doing. See, like this you are holding. So here what happens, sir? Coming in, coming out, going in. That, what about this? Just see this. See this. Here it is coming out, isn't it? Here also it is coming out. And what about this current? It is anti-clockwise, no? Therefore, all are in the same direction now. All will be in the same direction. See what are the bits given here. What are the options given here? First option is M-set problem, old M-set problem. Mu naught by 4 pi, mu naught by 4 pi, I by R into 2 plus pi. Second option, M-set they will give 1, 2, no. So mu naught by 4 pi, mu naught by 4 pi into I by R into 2 minus pi. Next, third option, mu naught by 4 pi into I by R into 1 plus pi. And last one, fourth option, mu naught by 4 pi into I by R into 1 minus pi. These are the options given. M-set problem, old, I told you last 2-3 years we are taking now. So 1 minus pi. Now let us see here. Already we identify this is B1, B2, B3 or B2, B3, whatever you want to take. So they are all in the same direction. They are all in the same direction. They are all coming out of the plane. They are all coming out of the plane. This is coming out of plane. This is coming out of plane. This is also coming out of plane. All are out of plane, just you have to add. So solution is, we have now the solution for this. B is equal to B1 plus B2 plus B3. So B1 and B3 are, B1 and B2 are same, no? B1 and B2 are same. Therefore, we can write 2 into mu naught I divided by R, 4R. 2 into mu naught I by 4R. Distance is R, no? Distance is smaller, capital R, smaller. It is given as smaller. So this is smaller. So smaller plus semicircle, for semicircle. So plus for semicircle. Semicircle we know already. Mu naught I by 4R. Isn't it? Mu naught I by 4R. So what is our final answer now? Mu naught I by 4R. So smaller, we have to take smaller because smaller is given. Now mu naught I by 4R we can take common. Mu naught I by 4R we take common. Then what remains? Here 2 remain. There is no pi. So we have to, here pi is there. 4 pi R. Isn't it? Here we have pi. For straight wire, pi is there, 4 pi R. So what remains? Here we get 2 plus pi, because here there is no pi. So what we will do? We multiply by pi and we divided by pi. So we multiply by pi and we divided by pi. So we are multiplying by pi and we are dividing by pi. Because no pi is there, we are taking pi common. Therefore, our final answer is mu naught I by 4R into 2 plus pi. So where is our answer? So first answer is correct. Option 1 is correct. Okay. So that is the way to do this. Right? Next. Let us go to next model. That is the magnetic induction at the center of a square of side L. The magnetic induction, the magnetic induction at center of square of edge L, edge L and carrying a current I, and carrying a current I. Il Tesla is, in Tesla. So what are the options given here? Let us see the given options. So given options are, they are given as for us root 2 mu naught I by A. First one, root 2 mu naught I by pi A. Second option, 2 root 2 mu naught I by pi A. Third option, option 3, mu naught I by pi A. And option 4, mu naught I by 2 pi A. So they are the options given, right? So now let us take a square. First let us take a square. So what is this A here given? Side A, this is given as side A, okay? Side A, edge A, not L, edge L. Edge A we have to take, this is A. So edge A, okay? Edge A. Now take a square. Take one square. This is the square, right? Now all are, see the direction of current given here, direction of current. So this is the direction of the current. This is the direction of the current. You want to find at the center. You want to find at the center. Therefore, we will take the center here. We will take at the center. So this point we want. So at this point we want, right? This is our center C, let us say. So now here this is given as A. Edge is given as A. Now what is this? Half of diagonal, no. So what is this total length of diagonal? Total length of diagonal equal to root 2A. Because this is a right angle triangle. This is a right angle triangle. Therefore, this will be root 2a, half of that. Root 2a by 2. Root 2a by 2. That is a by root 2. Sorry, a by root 2. Half of diagonal. Half of diagonal. That is root 2a. Half of the diagonal that we can write. So this is our square. Okay, that is the square. So this is what we are doing now. So this is a by root 2. A by root 2. A by root 2. Okay. Now direction we will see. What is the direction of this current? See, into the plane. Now see this. See this. Into the plane. You can see like this. Into the plane. Next. See the one. This one. Into the plane. This one. Into the plane. All are in the same direction. All are into the plane only. All are into the plane. Right. So all are into the plane. Therefore, just we have to add. And all are identical? No. They are all of same length only. And what is the distance? What is the distance here? Distance is this one? No. This is the distance. So this is the current and we want at the center. Therefore, we want this distance. What is that? Perpendicular distance? This one. This is the perpendicular distance. How much? A by 2. Isn't it? This is A by 2. And what is this angle? 45 degrees, 45 degrees, because it is a square, right? So if I take for each wire B, B, B and B, all are same, direction is same, magnitude is also same. Therefore, we can write the solution now. We can write the solution. B at center equal to 4 times B. 4 times B. That is equal to how much? We know already the formula from Biot-Savart's law. From Biot-Savart's law, we know the formula already. So from Biot-Savart's law, B is equal to mu naught I by 4R. Mu naught I by 4D. D we are taking. 4D into sin alpha plus sin beta. Sin alpha plus sin beta. Alpha equal to beta equal to how much? 45 degrees. Therefore, we will get now here final answer 4 times of that value. Right. So that is equal to how much? Mu naught by 4 pi d, sorry, mu naught by 4 pi d, right. So, current is given here. What is the current flowing? I only. I is given here. So, we can write here that is equal to, we can write, answer is in terms of mu naught I only, so no problem. So 1 by root 2 plus 1 by root 2. So mu naught I by 4 pi d into sin 45 plus sin 45. So that is how much? Mu naught I by 4 pi d into 2 by, because 1 by root 2, 1 by root 2, 2 by root 2, right? So that will get how much now? See that value, this is 2. Therefore, we will get mu naught I divided by 2 root 2 into pi d. 2 root 2 into pi d. Okay. So now into pi d, but what is d, sir? A by 2, no? So mu naught I by 2 root 2 into pi into a by 2, because this perpendicular distance is a by 2. Therefore 2 gets cancelled. So pi a we have. Now what is our value? 4 times of that value, no? 4b. Therefore our value will become now total b at center equal to, so b at center equal to 4 into, what is that value? Mu naught I upon root 2 pi a, right? So this we can write 2 root 2 mu naught I divided by pi a. Isn't it? Because 4 we can write 2 into 2 and 2 we can write 2 root 2. 1 root 2 has gone. So this we are writing like this, 2 into 2. That also we can write 2 into root 2 into root 2. So 1 root 2 gone. Then we have 2 root 2 mu naught I by pi a. That is our answer. So pi a, this is pi. So pi a. So pi a. So what is our correct option? Correct option is 2 root 2 mu naught I by pi a. So our option is, second option is correct. Okay. So second option is correct. This is very, very important model. Very, very important model. It is asked in JEE main last before year. Okay. Next, let us go to the next model. A pair of stations, this is JEE mains problem. JEE problem. A pair of stationary and infinitely long bent wires, a pair of wires, a pair of stationary and infinite long wires, bent wires are placed in the xy plane, xy plane, right? Xy plane as shown in the figure. As shown in the figure. Right, what he says? The wires carries 10 ampere current. The wires carries 10 ampere current. 10 ampere current. So what you want to find? So you want to find the induction at origin O. Find the magnetic induction at O. See what is given here. So two wires are given.